Alright, so back to the multiple choice. There is rates of reaction, equilibrium, and acids, bases left. I've worked out most of the rate of reaction question. I did not write out the equilibrium or acid-base question yet. It's okay, we can do that together. Right. 1.4. Two gases are added together in an empty container. So they are trying to tell you that these diatomic gases, yeah, those there, no, diatomic gases, two different diatomic gases is added together. They want you to answer which one of the following containers, in which one of the following containers is the initial rate the fastest. Okay, so in order to answer this question, you've got to remember that rates get influenced by concentration, by type or the state of the reactants, by the surface area, by adding a catalyst, and or by increasing or decreasing the temperature. Okay. At the same temperature. Fantastic. No catalyst involved. These are all gases. And so I can assume that they are all the same surface area. So the only one, pardon me, of the rate of reaction factors that we are looking at is concentration. Go. Concentration is number of particles per volume. So let's compare A and B. Can you guys see B has less particles in than A? So it cannot be B because A has more particles in. It will have a higher concentration rate. We are looking for higher rate of reaction. Alright, so let's compare A and C. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Can you guys see that A and C have the same number of particles of each of the reactants in? But C is twice the volume of A. Same number of particles, but much bigger volume. So it also cannot be C. And those two explanations to me weren't that bad. They were relatively logical, I don't know. But comparing D and A was a bit of a brain problem in my life. Okay? So I said, I don't know which one of the two is the limiting reagent. No cooking clue. Right? There's less of the dark stuff in than there is of the white circles. So I thought, well, you know what, maybe that's it. So here I had 3 of the dark particles in 5 cubic centimeters of the container. This side I've got 1, 2, 3, 4, 5, 6. So I've got twice the number of dark particles, but the container is 4 times as big. And if you therefore look at the relative concentration of A and D, you will see that even though there's twice as many particles, the container is 4 times as big. So this concentration is still less than the concentration of A. Okay. 1.5 was an interesting question because it's a little bit rate and a little bit equilibrium, but I'm going to deal with it now, and then I will go to question 5, the rates of reaction question, and we'll deal with question 5, the long form. Alright. You guys are awfully quiet, but there's also awfully few of you in here. I hope everybody's staying nice and warm. Alright. Which one of the following statements is true? Mean question. For the effect of a catalyst for a reaction at equilibrium. Reaction has already happened. Equilibrium concentration increases. Negative Ghost Rider. The only thing that influences equilibrium constant is temperature. Catalyst is not temperature. The rate of the reverse reaction increases. And my first feeling was, no it doesn't. The rate of both increases. And then I kept on reading. The activation energy for the reverse reaction increases. What does a catalyst do, guys? A catalyst decreases the activation energy. And if it decreases the activation energy of the forward reaction, it will also decrease the activation energy of the reverse reaction. So can't be C. The enthalpy change. Just remember, we don't know if it's endothermic, exothermic, doesn't really matter. Delta H is that distance there. Okay, enthalpy change. Reactants, products. Yes, with a catalyst, the activation energy is less. But the energy of the products and the energy of the reactants don't change. So it doesn't matter if it's forward reaction, reverse reaction, that doesn't change. So I had a look at the question again and I realized that they don't say only the rate of. I think it's mean. Okay, I really do think it's mean, because if they had said only the rate of the reverse reaction increases, maybe, but none of the others fit. The rate of the reverse reaction increases. Yes, it does. Okay? It's not only the rate of the reverse reaction, it's the rate of both. But anyway, not a cool question. It's, I suppose, fine. Alright. I will deal with 1.6 and 1.7 when we get there. Go. Let's have a look at question number 5. Question number 5, rates of reaction. Really nice question to start off with. The stoichiometry in here is insane, but that's fine. You guys should realize that the stoichiometry is going to be tricky, but it's one of those. Alright, so you've got a container. Do we all notice it is an open container? Initial mass of the flask, 144,50. Balanced chemical reaction, we know this happens. And then for 5.1, define the term rate of reaction. I hope I've drilled into you guys enough by now that the rate of reaction is the change in concentration of reactants or products per unit time. I know we never ever use this definition when we calculate, but do not forget that that definition is what you are expected to do. Alright. Then they ask you to write down one controlled variable, so one thing that stays the same. So obviously, if you analyze the thinking here, we are investigating the rate of reaction, right? And we need to go and figure out what is the independent variable. So we go up and we read the rate the reaction between magnesium carbonate pellets and excess dilute hydrochloric acid is used to investigate the effect of concentration on the rate of reaction. So our independent variable here is concentration. And because it's carbon dioxide pellets, and if you look at the next page, they give you the 3 experiments and the concentration of the hydrochloric acid changes. So the independent is the concentration of hydrochloric acid. That means that everything else that could affect rates of reaction is kept constant. There are many, you only have to write down one. I wrote down all of them. Okay, so you could keep the temperature constant. They are saying that the magnesium carbonate pellets, so the surface area, it is solid magnesium carbonate and hydrochloric acid solution, so the nature of the reactants are staying the same. I would assume, although they don't state it, but how else are we doing this, that the amount of magnesium carbonate also stays the same. So any of those would be your controlled variables or your constants. Okay. Right. So, here we get to the fun stuff. The experiment gives you different concentrations, and the incomplete, that means that this could carry on going. Right, cool, fantastic. The incomplete graph is there. If you look at these concentrations, can you guys see one, lowest concentration, then up, then up? Good. Why does the mass of the reaction mixture and the flask decrease? If you guys ever tell me that the glass suddenly weighs less, I will hurt you. It is an open container and a gas is formed. Okay. It is only a 1 mark question, so you could probably get away with writing either or, but anyway, I generally tend to write both because just now you have a snarky someone who says, no, but the fact that a gas gets formed doesn't matter. So, container is opened and a gas or carbon dioxide is produced. Alright, that is why the mass of the container decreases. Fun question! Incomplete graph. For curve B. For curve B. Calculate the average rate at which carbon dioxide is produced in the first 120 seconds. And this is where you guys will remember from last year when we did ideal gases, I said to you guys the only reason we're doing ideal gases in grade 11 and doing all of them, even though we only have to do Boyle's law, is so that when you see that the molar gas volume is not a 22,4, you don't freak out. Okay, it's a 6 mark question. I know it's a lot. Okay? If your stoic is not strong, you're going to skip 5.4 in a test or an exam, but you are still going to be able to do 5.5 and 5.6. Okay? Do not do the next questions just because the one above it is slightly harder. Alright. So, average rate at which carbon dioxide is produced. Go. Carbon dioxide is a product. When it is a product, the formula is rate is equal to change in concentration divided by time. When it is a reactant rate that you are using, so let's say determine the rate at which magnesium carbonate is used, you would use that negative there. You guys need to be careful. This formula here, the positive is given for both. It is incorrect in your exam guidelines. The one in your exam guidelines for products are fine because it's positive. The one for the rate of reactants is negative, which is the one you need to use when you are calculating the rate at which reactants get used must be negative. Your exam guideline gives it as positive. That is incorrect. Okay. Now, further on this question, they say in cubic decimeters per second. So, we need to know the final volume of carbon dioxide produced minus the initial volume of carbon dioxide, divide by the time it took. That's the 120 seconds. Right. When the reaction starts, there is no carbon dioxide. So the initial volume of carbon dioxide is 0. All right. This is the problem, is getting to the final volume. And that final volume of carbon dioxide is why this is a 6-mark question. Okay, here we go. First things first. Back to my incomplete graph. I started with initial mass. Okay? And final mass. You guys see that? Wait, where's the balance equation? Can you guys see the only thing that is disappearing out of my reaction is the carbon dioxide? So that is the mass of carbon dioxide that is disappearing. Okay, so when I'm thinking about this question, I'm going to say that. I'm going to say mass of carbon dioxide is equal to, sorry guys, I half scribbled down my thinking here, 144, the initial mass of the container, minus 143,87, the mass of the container and its contents at 120 seconds for reaction B. And when I plugged that into my calculator, I got 168 grams. This is going to be worth a mark, being able to do that. And so, or you guys probably could go straight from mass of carbon dioxide to mole to volume. It is dangerous. I know that there are going to be channels on YouTube that show you this. Just be careful. So the molar mass of carbon dioxide, you do not need to write this out. What I do think you need to write out is how you determined what the number of moles of carbon dioxide produced is. So we've got that mass, the 0.63 that disappeared out the container. Okay. Of course, 0.0143, and now I get 18 repetitive. Okay, so that means that 0.0143 and change moles of carbon dioxide was produced. They want to know what volume that is. Again, I would be careful not to write the formula for just in case. I want you guys to try and leave these values in your calculator, okay? And now here we are going to use this molar volume that they gave us because it's probably not at STP 24,5. Right, 24,5. 0,35079 and change. Okay, so this is the volume of carbon dioxide produced, which, if we go back up there, is that final volume that we wanted there. So the rate is 0,35079 and change. Remember, I've left this all in my calculator. If you round too early, guys, your answers are going to be out. Oh, 0,0029 and change. I think the answer they're looking for is 0,003, and they're looking for it in cubic decimeters per second. Alright. If anyone else has a different thinking about it, you need to speak up so that we can have a look and see. But my stoic is relatively strong. Okay, you ask exactly the question that I have you ask the question that I have an issue with. Okay, so have a look here. For curve B, calculate the average rate at which carbon dioxide is produced for the first 120 seconds in cubic decimeters per second. Remember when I said to you the definition is change in concentration of reactants or products per unit time. And in your exam guidelines, the formula that you get given to use is rate is equal to change in concentration divided by change in time. But they are saying to you they want the rate at which carbon dioxide is produced for the first 120 seconds. So yes, the delta T is still there, but you cannot give them the concentration of the carbon dioxide because the container is open. The carbon dioxide is disappearing. Like, what? Is it going to be carbon dioxide in the universe? Like, how do we know that concentration? How do we know the volume per mole that carbon dioxide is in? So that's why I have an issue with the fact that they are stupid about the definition, having to say it is the change in concentration of reactants or products per unit time. But when you are ever asked to calculate, they give it to you in here, it's volume of gas produced per unit time. So when you are doing rates calculations, you always have to look out for the unit that they are asking you to give it in. Sorry guys, I've gone into fuzzy focus. There we go, that's better. You always have to look at the unit that they are asking you to calculate in. Okay. Really, really not easy. I don't particularly like how they ask this question. I'm sorry. Okay. Right. 5.5. Okay, I hope. Yeah. Let me know if it doesn't answer your question, then I'll go and see if I can find a video that better answers that question, because, you know. Okay, which curve represents experiment 1? So, experiment 1 is the one with the lowest concentration. And so we expect experiment 1 to be the curve that represents the reaction that has the lowest rate. The one that, if I take a ruler, has got the smallest gradient. Right, so I hope you guys can all see that that is A. Okay, so for 1 mark, A. For 4 marks, use collision theory and explain your answer. Okay, and here again is where my brain got a little bit confused, because what are the marks for? All right, so hang on, let's pull this off and put my thinking scribbles on. I'm quite finished thinking about it, but you know. Go. So experiment 1 has got the lowest concentration, and therefore it must represent the graph with the slowest rate, which is y graph A. Okay, so this is kind of where my brain ran out of time yesterday. At low concentrations, okay, lower concentrations in reactions will result in fewer or less smaller reactant particles, molecules, atoms, doesn't really matter how you want to verbalize that. Okay? Will result in fewer reactant particles. This causes fewer collisions per unit time. A nicer way to put that would be to say that the frequency of, and I would prefer the word here just for in case, of effective collisions are less, fewer, smaller. Good. Therefore, the reaction rate will be the lowest. Now that gives you 4 marks. No, 1, 2, 3. I cannot, for love or money, tell you where I think the 4th mark is, unless somehow they want you to make that top statement. I'm being very honest with you guys. This is a really heavily marked question, as in there's a lot of marks in it. I know curve A would get you 1 mark, but it is a 5-mark question. My brain can get another 3 marks. I don't know where the 4th mark is, unless they want this statement. Okay. Right. Hang on. So that was 5.5. Now, 5.6. Question paper. How will the final mass of carbon dioxide produced in experiment 2 compared to that of experiment 3? We use different concentrations of hydrochloric acid, but the hydrochloric acid is always in excess. The concentration of the HCl during each experiment does not change. I don't quite know what they mean by that. The mass of all the containers start out being the same. And so I can only assume that you're starting with the same mass of magnesium carbonate in each reaction. The mass of the magnesium, in my opinion, if I look here, will therefore be the limiting reagent. And so I cannot see any situation in which the final mass of carbon dioxide will be different in any of these experiments. So in my opinion, the final mass of carbon dioxide produced will be the same in all the experiments because MgO3 is the limiting reagent and the mass of the reactants are the same for all three experiments. It's a very weird way of asking that question. I'm not quite sure what they were trying to elicit or get from that question. Maybe because they gave incomplete graphs and thought that maybe you guys would think that it wouldn't get to the end. I don't know. But that is my opinion on that question. Alright.